Hello and welcome to this tutorial video on GCSE Maths. Today we're looking at trigonometry, or SOHCAHTOA as some of you may call it. This comes up quite a lot on both the foundation and higher papers, so if this video helps you out, then leave a like and hit that subscribe button to be informed of whenever I upload a new tutorial. So before we even start answering trigonometry questions, the first thing we have to address is what the heck have I got written on my screen? This is SOHCAHTOA. And if you're not familiar, each of these letters stands for something whenever we're doing trigonometry questions, okay? So, the S stands for sin or sine, the C stands for cos or cosine, and the T stands for tan or tangent. Now, you should be able to find those on your standard sort of Casio scientific calculator. Now, the O, H, and the A, these all stand for what we call the different sides on a right-angled triangle. So, the longest side of a right-angled triangle, and you see we're going to use the example that I've got here, this is always known as the hypotenuse, okay? So the longest side, or the side opposite the right angle, is our hypotenuse, and that is represented by an H. Now the other two depend on what values we have around our triangle. You see we've got a length of 10 here on the bottom, and we've got this angle of 40 and our right angle. Now the adjacent, which is our A value, is in line with both of the given angles, okay? So the 40 and the right angle in this case means that this bottom side is our adjacent. And over here on the left, that means the only side left is the opposite. So, hypotenuse, adjacent, and opposite. Whenever you start a trigonometry question, you should be thinking about labelling the sides of your triangle, and then you can work from there. So just to get used to the idea of labelling our triangle before we start a question, have a look at this triangle here, and see if you can pause the video and work out which one you would label as the hypotenuse, which one you would label as the adjacent, and which one you would label as the opposite. Okay, well the most obvious one is always the hypotenuse. It's opposite our right angle, and it's the longest side of the triangle, so that's going to be this side right here, the 12. How about the adjacent? Well, we know the adjacent is in line with both of our given angles, so that's going to be right here. And by process of elimination, the opposite is going to be this side down the bottom, length 3. Alright, so heading back to the question we saw at the start, as we worked out before, our hypotenuse is this side, our adjacent is the one down the bottom, and the opposite is the side on the left. Right, now back to our SOHCAHTOA that we had, and as you'll see, I write it horizontally this time, rather than going downwards. And you might be thinking, why are you writing it in the way you're writing it? Like, what are you doing right now? Well, let me explain. Basically, we need to pick which one of these we're using, and then you'll have either opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. It'll be one of these three fractions. So, the one we pick is based off of which sides we have information on. So, we've got information on our adjacent, 10 centimeters, and we've got information on our hypotenuse side, this length x. So A and H. So, do we pick SO, which has O and H, CA, which has A and H, or TOA, which has O and A? Well, we have A and H, so we're going to pick CA, which means we're going to use cos in this particular question. Regardless of whether you have sine, cosine, or tangent, the method is going to be very similar, and just switching out whichever one you need to use, okay? We're going to write out the following equation. Cos 40, so the cos of this angle 40 here, is equal to, and this is where those fractions I was talking about comes into consideration here. It's going to be the adjacent over the hypotenuse. So our adjacent is 10, and our hypotenuse is this unknown of x. Okay, we've now formed our equation, so we just need to do a little bit of rearranging and solve to find x. Okay, well, I don't like the fact that this x is down here on the bottom of this fraction, so what I'm going to do is times both sides by x. And that's going to give me x cos 40 equals 10. But we're still not there just yet. We need x to be by itself. So what I'm going to do is divide both sides by this cos 40 that's here. So divide both sides by cos 40. And what we get is x equals 10 over cos 40. So what you can do is just plug all of this into your calculator and it will give you your length, your final answer. And what I get in my calculator is 13.05. Okay, so we've got a very similar question here to last time. So let's use the same method and try and find the value of x here. So what's the first thing we do? We label the sides. So as always, the hypotenuse is opposite the right angle there and is our longest side. The adjacent is in line with both of our given angles. And our opposite is over here, again on the left, okay, being the last one we do. Now, let's write out SOHCAHTOA. Now, the more times you write this out, this SOHCAHTOA, you will start to memorize it. Now, there are some ways of making each letter represent a word to memorize it. Silly old Harry, etc., etc. I will leave you to research those by yourself. Some of them are quite rude. Okay, so now we have to find out if we're using sine, cos, or tan in this particular case. So again, we look at which sides do we have information on. So the h has this 16 centimeter length. And this O has an unknown length of x. So it's the O and the h. So is it sine, cos, or tan? It's going to be sine, okay? We look at the O and the h, and that's what we have here. So again, thinking of this as being a fraction, we're going to basically do sine 30, in this case, our angle's 30 this time rather than 40, equals, and O over h, so O is x, and h is 16. So this time, this is our equation that we've formed. And once again, we're going to have to rearrange it to find the value of x. So in this case, the x is on the top of the fraction. So rather than doing what we did last time, we're going to times both sides by 16. This gives us 16 sine 30 is equal to x. And so in this case, we're actually ready right away to put that in our calculator and find out the missing length. And as it turns out, 16 sine 30 gives us the lovely value of 8. And don't forget the unit here, centimeters. So we'll just do one more question here, and this one, you might notice it's slightly different. So rather than being given one length and one angle, we've been given both lengths, and we're being asked to find out the missing angle. But don't let this discourage you, because the method is actually very similar up until right near the end. So once again, we start off by labeling our sides. So the hypotenuse is down here, opposite the right angle. The adjacent, is it going to be the left or the top? It's going to be the top, isn't it? Because these are our two angles that are given. So there's our adjacent, and therefore the opposite is over here on the left. Okay, now once again, let's write out SOHCAHTOA. And let's have a think. Well, we've got information here where the O is, and here where the A is. So that's actually O and A. We're using TOA or tan in this case. This time we've not been given that angle, so we're going to put tan x, and then once again, O over A, our little fraction. The O is 9, and the A is 20. Okay, so there appears to be a problem with this equation here, and that is that we're looking for the value of x, not the value of tan x. Once again, look at your calculator, and what you should notice is that above the sine, cos, and tan, there should be a little thing which says sine to the minus 1, cos to the minus 1, and tan to the minus 1. Now these are your inverse trig functions, and we're going to use these whenever we're looking for a missing angle rather than a missing side. Because we're looking for x and not tan x, you can say x is equal to, and then moving the tan to the other side, it becomes tan to the minus 1, and then you still have 9 over 20 like you did before. Okay, so upon moving tan across from the left to the right, it's now become the inverse function, and now we can stick that in our calculator. Don't forget, you usually have to press shift before you press the tan button, and that should make that come up. Okay, and the angle that I have upon putting that in my calculator to one decimal place, let's say, is 24.2. And the degree symbol's already there, but if it's not, it doesn't hurt to write it in.